Hello everyone. Now let us see the another numerical which is given as a galvanometer with a full scale current of 10 milliamperes has a resistance of 1000 ohms. The multiplying power, the ratio of measured current to galvanometer current of 100 ohm shunt with this galvanometer is. It is asked in GATE 2004 and here are the options. So before solving any numerical, let us see what is given in that numerical. Here it is given as a galvanometer. Galvanometer is nothing but the permanent magnet moving coil instrument, that is the pmmc instrument. After reading this complete numerical, you can get or you can extract the data that this complete numerical is based on the pmmc used as an ammeter. When pmmc used as an ammeter, according to that we have to solve this numerical. So for that it is given the full scale value of current. Full scale value, that is nothing but the meter current. That means the maximum current which will pass through that meter. So it is given as the 10 milliamperes. Has a resistance of 1000 ohms. Every meter has its internal resistance. So that meter resistance is given as the 1000 ohms. And 100 ohm shunt. 100 ohm shunt, why it is given? Because we are using the PMMC instrument as an ammeter. For that we know to measure extra amount of current or higher amount of current, we connect the shunt. So here that value of shunt resistance is given, that is nothing but the 100 ohm shunt. And what is asked? That is the multiplying power. Multiplying power you can say, multiplying factor you can say, which is denoted as M. So these are all the given data. So what is given? The full scale value of the current is given, that is nothing but the meter current 10 milliamperes. Meter resistance we are denoting as Rm, it is given as the 1000 ohms, and the shunt resistance which we are connecting in parallel with that ammeter, it is given as the 100 ohms, and it is as the multiplying factor, that is the M, which we have to find out. In the numerical, it is given that the multiplying factor is given by the measured current divided by the galvanometer current. That is the ratio of the measured current divided by the galvanometer current. For that, consider this diagram here. Measured current. Which current we have to measure? We have to measure this current, that is the total complete current which is flowing in the network, that which is denoted by I. And the galvanometer current. Galvanometer current is nothing but the meter current. It is nothing but the full scale value of the current. So that meter current we are denoting as IM. So we have to find out this value of multiplying factor, which is given by measured current divided by the galvanometer current, and which is nothing but I by Im, ratio of the measured current divided by the galvanometer current or the meter current. In this complete diagram, you can see this is nothing but the ammeter, or you can say the galvanometer, whose internal resistance denoted by Rm, and the current flowing from that meter is denoted by Im. And we are connecting the shunt resistance because we have to measure the higher amount of current. For that, when PMMC used as an ammeter, in that case we are connecting the shunt resistance in parallel. I already told you this thing. So here this shunt resistance is connected in parallel with this ammeter. So it is denoted by R shunt, or you can say RSH, and the current which is flowing from that shunt, it is denoted by ISH. Now to solve this or to find the multiplying factor, first of all consider here, or you can see here in this diagram, these two are the parallel branches. So in parallel branches we know that the voltage drops across the parallel branches are same. So here the voltage drop across this shunt branch and the voltage drop across this meter will be same. Voltage drop is nothing but the product of the current and the resistance. So for this shunt branch you can write it as ISH into RSH, and for this meter you can write as Im into Rm. So this will be your equation when the voltage drops are same, because both are connected in parallel. From, or you can say it is, we are denoting this equation as equation number 1. In this complete branch, you can see these two are the parallel branches. So this measured current, that is the complete current I, is nothing but the addition of ISH and Im. So here we are writing the value of I is equals to Im plus ISH. Here, why we are writing this thing? Because in this formula you can see Rm is known, Im is known, RSH is known, but ISH is unknown. We have to find out the value of ISH, or we have to replace this ISH by the another terms. For that we are doing this process. So in this we can see the complete total current I is nothing but the addition of the meter current plus the shunt current, that is the ISH. From this find out the value of ISH. So ISH becomes I minus Im. Now this value of ISH substitute in equation number 1. So what we will get? This equation, that is I minus Im into RSH is equals to Im into Rm. Now open the brackets here, simplify it. By opening this brackets, you will get this equation. Now shift this term, that is Im into RSH, to the right hand side, so it becomes the positive term. So here when we are shifting, it becomes the positive term, and from this right hand side take the Im as the common, so we will get the equation as I into RSH is equals to Im RSH plus Rm. This will be the equation. Now from this equation find out the ratio, or take the ratio of I by Im. So here we are taking the ratio of I by Im. Now you can get the formula as RSH plus Rm divided by the RSH. We know that this I by Im is nothing but the multiplying factor. We had already seen, or it is given in the complete numerical. It is given in the numerical that the ratio of the measured current divided by the galvanometer current is nothing but the multiplying factor. So here you can see the measured current, which we are denoting as I, and this meter current or the galvanometer current, the ratio of this will give you the multiplying factor. Now in this formula all the values are known. RSH is given, Rm is given, and RSH is given. So substitute all the values in this formula. What are the values? That RSH is 100, that is the shunt resistance. Rm, that is the meter current, it is given as the 1000. So when we are substituting all the values, what we will get? The multiplying factor is found out as m is equals to 11. This is the value of the multiplying factor. From the options you can see which option is correct. The option number C. So here option number C is the correct option, that is the 11. Multiplying factor is coming out to be 11.